Hello, everyone. Good morning, and thank you very much for attending this session. I really appreciate your time and interest with us, and hopefully will be some good information for you. Let me go ahead and share our screen. Okay, great. So Wi-Fi, what does this mean to your subscribers and you? So I would say majority of us are using Wi-Fi of some sort somewhere. And we understand all the frustrations that are going on with it, as well as the providers with their subscribers. A lot of it has to do with, the coverage area. And the closer you are to your gateway, the better the connection is going to be. But as you start moving further out, it starts to drop off a bit in the performance. We run into some of those issues. A lot of that has to do with all those connections. So too many connected devices. 20 years ago, believe it or not, we may have had like 4 or 5 different devices, but now we are seeing in excess up to 20, 25 devices connected in the home. And just not enough resources on that poor gateway, that Wi-Fi router, to allow all those new connected devices to share the internet connection. There's only so much bandwidth to go around. By design, it was a kind of a round robin 1-to-1 ratio. And like I said, 20 years ago, we didn't experience any issues because we only had a few wireless devices. But now up to 20 devices, it could take quite a while to get to all those devices, communicate with each of those. Wi-Fi is a constant communication. Even if you're not even using that device, you'll see some of these autonomous devices, all these IoT devices in your home, they're actively talking and communicating. That's how Wi-Fi works. So as you add more devices, it starts to add up the toll on your gateway and use a lot of the resources, which takes up a lot of time. That's why Wi-Fi 6 comes into play, and we've really seen the advent and kind of making that change into a new threshold for wireless. So about 4 times the speed that we would get compared to what we've been using right now with the 11AC, or we call Wi-Fi 5. Also, the connected devices, larger capacity, 4 times the amount of connected devices. So even in a large environment, we're going to have really good performance. This also helps with time-sensitive applications. The lower latency, that time, that delay it takes from when you press a button on your device and it goes out to the internet and then returns, is latency. And Wi-Fi 6 helps improve that with some error time techniques. And for all the mobile devices, we know that there's quite a few mobile devices out there. You're going to see an improvement of the battery life because we're always constantly having to charge these devices, because since Wi-Fi is a constant communication, it uses a lot of battery time. And there's techniques in there that we'll talk about that help improve that. So 4 times faster, you see a 30-40% improvement over that Wi-Fi 5 or AC that we've been using for quite a while. So 4 times the performance with a Wi-Fi 6 network and gateway. That's due to the combination of radios and antennas. As you can see from devices, they may have 1 to 2 types of radios built into it. Extenders could have 2 to 3. And then routers that are Wi-Fi enabled, obviously going to have anywhere from 3, 4, and even 8 radios built into the device to help improve the connection. So when you're trying to source a product or just understand what these products can do, our industries pulled together a kind of a classification to give you an idea of what these products can do. As you can see from the bottom there, those are more of the client devices that we'll see that are AX or Wi-Fi 6 enabled. And it's a combination of that 2.4 band and the 5 gig band working together to be able to provide that speed. So we see on the device classification, it says AX 1500. As you move up that ladder there, you'll see the higher end where like an AX 5700 or AX 6000, you can see that there's a combination of 1000, 148 megabits, and then on the 5 gig, 4800 megabits. So you can see there's quite speed performance there. And as you notice in the AX 1100, there's the ability of up to 10 gigs in wireless performance. So more connected devices, so 4 times that capacity. And actually, Wi-Fi 6 works better if you add more devices. The more, actually, the merrier it's going to be for your wireless environment. There is going to be support, so don't worry if you have wireless N or wireless AC products in your network. They're still going to be supported, and they're still going to work in concert with a Wi-Fi 6 device and clients. So everybody's going to have the ability to interconnect. There's no reason to get rid of those devices or hunt for new ones, because you can still utilize these products for some time now. So with all these wireless devices connecting together, they kind of aggregate and they kind of work off each other and help improve the network and push communication out, just like you would in a giant beehive and everybody's swarming around. It builds off that. So the bigger the network you build in home with Wi-Fi 6, the better the communication is going to be. So the overall performance, there's going to be performance obviously with Wi-Fi 6 devices, but also your Wi-Fi 5 and Wi-Fi 4 will also benefit as well. Those devices should get their top speeds, whatever they're rated to go to, whether it's 11 AC or Wi-Fi 5 or 11N, it's going to have that same performance and going to be able to provide that connection up to those devices. So even though you have this Wi-Fi 6, you're still going to have benefits for your legacy devices. For those mobile devices, there's going to be a lot of those. We see in smartphones, tablets, anything with a battery and utilizing Wi-Fi, it's going to take a toll on that. Utilizing techniques called target wake-up time, that's going to help improve the performance of your wireless network and give you that ability to kind of save some of the resources, especially the battery life for those devices that are mobile, and help improve the performance. So it's going to look to negotiate with that Wi-Fi 6 gateway and see about specific times it can communicate. With other devices in the mix, it's going to also help reduce the contention or fighting for resources. It's going to line everybody up so they all have a chance to communicate. And in devices that are mobile, usually they have a kind of a sleep time. It's going to utilize that as well to help reduce the power consumption in certain aspects, so it doesn't always have to transmit, thus improving your battery life for mobile devices. Built into the gateway is an intelligence. It can control and manage all those connected devices more so than we have in the past. It's actually can send down configurations to devices like an extender and tell it what to do and allow that to manage other devices that are actually connecting to it. This is all done also with a single SSID, a single wireless network. So you see two devices there, a gateway, a Wi-Fi 6 gateway, and an extender. It'll treat those as a single device, and you'll have just one SSID network to connect to. So when you look on your device and do your site survey, that's all you have to select. So you don't have to worry about 2.4 this or a 5 gig that, or you just look for one wireless SSID and you're ready to go. Very simple. At that point, the gateway is going to take over and help balance out your network and distribute devices to specific radio frequencies like a 2.4 or 5 gig and their proximity. So it analyzes the network and it takes an account of everything that's connected. And if there's too many devices that are on one band, it can actually move other devices to another band and doesn't require any intervention from the subscriber or yourselves to do that. It's all automatic. So the gateway kind of acts like a traffic cop, and it kind of determines where you need to go. So you don't have to really worry about, again, trying to select a specific band to go to. At one point, you may be connected to the gateway And then at another point, you could be walking around and being connected to the extender if there's one installed. And at one time, you may be on 2.4 or you may be on that 5 gig. That's part of the roaming. So you can roam around from place to place. In the past, without this type of environment, what would happen is when we get to the edge of that Wi-Fi router, we probably would have a weak signal or disassociate, and then have that little gap in time where you disconnect. And then as soon as you get closer to an extender, if you have one installed, then you would associate to that and connect to that device. So in this environment, you can be able to walk from one end to another and maintain that one single SSID throughout the whole premise or in a small office, and not have to worry about that annoying disassociation and reassociating to these other devices. It's still happening in the background, but we don't see it. All we know is we're still connected. Then with mesh networking, the ability to have a cohesive network and connections anywhere, these extensions or spokes, as we call them, allow us to extend our wireless network. In this fashion here, we can actually extend off an extender and really have the ability to cover large areas where we're looking at 4,000, maybe 5,000 or more square feet in a premise in a home, to be able to put a system in place to help provide coverage in those annoying dead spots that we run into. That's part of the Easy Mesh standard by the Wi-Fi Alliance. So it allows us to extend that wireless distance. You can have the ability to automatically onboard and connect and configure devices. It also has a self-organizing, self-managing system built into it. So it can take into account what devices are, where to need to distribute those to different points in the network, and actually extend off certain extenders and allow you to expand your network. And, in the coming months, we have this interoperability where you will be able to eventually add different extenders from different vendors to be able to create your network. So the idea is for that subscriber and user to be able to go out and source a product, maybe at a big box store or online or even from the provider, and be able to put that in and know that it's going to work in their network environment with ease of use. With distances, still it's kind of up in the air. There's just unfortunately not enough Wi-Fi 6 devices out there in the market that we can actually get some good testing for. So we're still reliant on internal testing with a lot of vendors. Even myself, I'm doing this test myself in the past. Wi-Fi 6 gateway inside the house, and then walking outside with mobile devices on the smartphone and a tablet device and being able to get some distances. Obviously, everybody's home is going to be different, so your results will obviously going to be different as well. But you get an idea that, you're going from inside a house with walls and the material, and then walking down in the neighborhood, with your mobile wireless device on Wi-Fi and getting some pretty good distances and performance. So taking a look at what's under the Wi-Fi 6 technology hood, there's several techniques and technologies here we see, like multi-user MIMO, OFDMA, quadrature amplitude modulation, the beamforming, and 160 megahertz channel width. Let's take a look at some of that. So we've known MIMO for some time now. It came out with wireless N several years ago. And then with AC, we had an advent of this second version, or we call Wave 2, which provides what we call multi-user MIMO. So multi-user MIMO, as you can see from the original MIMO, more communication, simultaneous communication, 4 devices at one time, as opposed to a 1-to-1. So pretty significant improvement. But with Wi-Fi 6, we took a step even further, and we've allowed for a bidirectional communication with multi-user MIMO. So not just in the downstream from the gateway, it's also allowing the clients to send information back up. So a huge improvement over what we've seen in the past going into this Wi-Fi 6. Airtime transmission techniques. We use orthogonal frequency division, multi-access, and in the past we've had it where And since I travel, I use the travel analogy with planes. At the airport is the gateway. And from there, you board your plane, right, in different destinations. Web surfing, video streaming, social media, gameplay, could be different ones. And you go to your plane, and sometimes some of the planes are pretty packed out. Other times, some of the planes are not, as you can see. So what we've done in our industry with Wi-Fi 6, we updated the airport, right? In this example, off to the right, with orthogonal frequency division, multi-access. So taking it a step further, what we do is we use a larger plane and cram as many people we can, just what the airlines are doing, and hit multiple destinations, all those layovers that we got to hit to. So we still get to those spots, but it's a more efficient way of utilizing the airtime to transmit the wireless signals, as opposed to sending different airplanes out, and some planes are not completely full. Also, we use quadrant amplitude modulation. Basically, more data paths. All those little dots that you're seeing there are the abilities to send data through channels or through like a highway. From Wi-Fi 5, we had 256, where on Wi-Fi 6, we're increasing that twofold here with 1024. So, of course, it's going to be a higher data paths to improve that communication. Also, with beamforming. Beamforming in the past came out back a few years back with the wireless end, and it wasn't really maybe highly utilized because the networks were a lot smaller. But nowadays, it's pretty applicable. In the past, with no beamforming, you can see on the far left, omnidirectional, it just sends signals out everywhere, just like a network broadcast. And if there's a client there or not, it doesn't care, just sending signals out, kind of wasting its time and resources. But with beamforming, it makes a connection to a device by sending signals out. And once it locks into a device, it remembers that device, kind of like a path to it, or maps it out. And can always know that device. Even if it's mobile, moving around, it'll still follow that device around, which improves the airtime, makes a dedicated connection to that device, thus saving resources and time and energy with transmitting and receiving signal. Also, with Wi-Fi 6 is the ability of channel bonding or channel width. And you'll see this in the Wi-Fi, especially on 2.4, on 5 gig, we'll see that, we have the ability of 20 megahertz and 40 megahertz channels, and we're just actually doubling that out. It's okay to use just 20 megahertz. It's a tried and true, less retransmissions, but it's a slower communication. To improve upon that, we've added the 40 megahertz is just doubling 220s into 140, and it does improve the performance. But there are some drawbacks. There are some issues sometimes with retransmissions, or we have to resend signals across. But that's okay. We accommodate that. We're used to that environment. And then with 5 gig and 11 AC or Wi-Fi 5, we've included the 80 megahertz, pretty standard that we see. So it doubles that 40 megahertz into an 80 megahertz channel. Then we released with the 160 megahertz. Only a few devices in Wi-Fi 5 had support for this, but really it's prevalent in Wi-Fi 6. And being able to have real high throughput when you look at your wireless device, whether it's the gateway or your client, really going to have high performance. This is the true over 1 gigabit performance. So you see 1200 megahertz, 1300 megabits or more. And if you have an environment where you have a Wi-Fi 6 gateway that supports 160 megahertz and the extender on that side, you're creating a really end-to-end wireless solution that helps the performance go through really quickly. So at first, not much difference. If you just have a Wi-Fi 6 gateway and a Wi-Fi 6 client, maybe 1 or 2. Not till you start building your network up. Then you'll start noticing that difference. Again, with that aggregation, that hive mentality that's going to take place, you're going to see that performance shoot up. So if you have up to 20 devices or more in your home, you're going to really notice that. So a big difference between the two, just high level. It looks like the same hardware, same radio and antenna configuration. But as you start peeling back the onion on Wi-Fi 5 and Wi-Fi 6, you'll see the huge benefit of the speed and performance there. And then the ability of this 160 megahertz, which is not available there. And then the MIMO downlink, the multi-user MIMO, where you have uplink and downlink. And the different design in the mesh environment. So just a little bit deeper dive into the technology, just give you a glance at what this is. We can support 160 megahertz, almost 10 gigs on Wi-Fi 6 AX. So the roadmap, we're pretty much done here. We're already at the tail end of 2020. We've gone through all the trials and tribulations, the plug fest, and the vendors are already starting to release their devices. So we're pretty fortunate that we're moving forward. But at the end of 2020, we'll start to see the advent of a new spectrum coming out, 6 gigahertz. And we've seen this discussion already take place in January. Wi-Fi 6E. Wi-Fi 6E is going to give us a new band to utilize. We just know that there's just too much congestion. Even though there's a lot of devices, we're still going to have some interference somewhere. So open up a new band. So the FCC's opened this up, this 1200 megahertz spectrum for 6 gigahertz. And we're going to utilize this for the 6E. So this will take some time to build upon. So there's no need to wait for Wi-Fi 6E right now. If you're thinking about jumping into Wi-Fi 6, just do it. You'll see the benefits. It's going to be a couple years out before we really start to see the Wi-Fi 6E take off, and then we see those consumer devices, the mobile devices, the phones, and laptops. It'll be a couple years before we'll see that. But just to be aware that we are continuing to progress and move forward with our technology. Managing all this with Wi-Fi 6 is very applicable, especially for providers. That way they can save costs on support. So you can monitor all those wireless devices, update the passwords, again, add guest networking, new devices, and then do instant troubleshooting, and then help with the parental controls over the wireless. Zero touch means the provider doesn't have to go anywhere. If they're using an ACS and a TR69, they can do this all remotely and manage the configurations, firmwares, reboot the device, all through the TR69. Also, with your Internet of Things, we've introduced the new TR369, what helps. That's a user service platform. It's going to help with all those IoT devices that are traditionally not TR69, but builds profiles and allows you to control, configure, and manage these devices for your subscribers with this technology, built in broadband form specifications. Also, a lot of the remote management systems, especially TR69 and ACS, can be built into your BSS OSS systems. So you have a full cohesive ecosystem to manage your subscribers from the minute it ships from your distribution partner, then to your warehouse. You track that thing, and then in the post-sales support, you can help that subscriber out, and it's all in one cohesive system. So what we've learned is quite a few things. We talked about the challenges of Wi-Fi, the benefits of Wi-Fi 6, the radios and antennas, the classification, more connected devices, benefits for Wi-Fi 4 and Wi-Fi 5, the battery life. We talked about mesh. Not much difference at first. We also talked about the differences between Wi-Fi 5 and Wi-Fi 6 hardware, as well as the technology roadmap. We did talk about the what's under the hood, as well as the management of Wi-Fi 6. To take a look at some quick resources, if you're interested in more information about Wi-Fi, go to Wi-Fi Alliance. They have great information there that you can get and download and read, as well as Broadband Forum for all that remote management capabilities that you're looking for in your network. If you're interested in learning more about what you've seen, or you can go to our website and look at the product information for the Wi-Fi 6. You have data sheets, users guides, and quick install guides, as well as pictures and specifications. Contact us at broadband@zyxel.com, or if you already know Chris Lanier, who's your regional sales account manager, contact him there. And this is our team, his counterpart in the West, as well as our director, Bob McMillian, which I think most of you kind of know, myself, and our inside sales, G Tran, who helps put us all together and get those products shipped to you. And I want to thank everybody very much for taking the time and interest with us. I really appreciate it. Hope it's been helpful for you. And if you do have some questions, please feel free to reach out to us, and we'll be happy to have some discussions with you, as well as spend some time during the networking and come by our booth and have a talk with us. Thank you very much. Really appreciate it.